Our final guest this evening is passionate about science and research and their breakthrough potentials. Yuri Milner can be described in many ways. He's a physicist, he's a businessman, he's an entrepreneur, he's a philanthropist. He realized early on the value of scientific thinking, and he's applied this in his investments and in his transformative approach to supporting science and to recognizing the contributions of scientists worldwide. With his wife, Julia, they've supported incredible research here at Stanford and many, many other places. And in 2012, they founded the Breakthrough Prize. The Breakthrough Prize, it's been called the Oscars of Science. The Breakthrough Prize recognizes contributions that have been made in fields such as mathematics, physics, and various fields of biology. Many Stanford faculty have been recognized with the Breakthrough Prize. And in biomedical sciences, advances in Parkinson's disease, in the treatment of multiple sclerosis, in fundamental research that's leading to new understanding of the brain, in various areas of cancer research, all have been recognized through the Breakthrough Prize. And having had the opportunity to talk with people who've received the Breakthrough Prize, it's so meaningful. It's so meaningful because of the support and the recognition for their life's passion in research. But it's also so meaningful because it brings together the ceremony, the activities, bring together people from so many different walks of science, but also so many different avenues of society and of accomplishments. So please join me in welcoming Yuri Milner. Thanks for being here. It's good to see you.
Thank you.
So you began your career as a theoretical physicist, and then you attended Wharton and began pursuing a business career. Can you tell us what first attracted you to science?
Well, I tried to say it in my book that I wrote a few years ago, which is called the Eureka Manifesto. And the subtitle is The Mission for Our Civilization. And in this book, I try to make the case that the mission should really be understanding of our universe, which is science. And I suggest to maybe for everybody to do a thought experiment with me. So one of the projects we are funding is called SETI, Search for Extraterrestrial Intelligence. So our foundation committed $100 million to that project. So we have not found the signal yet, but let's assume that this civilization exists, and let's say it's 10,000 light years away, which is 10% of Milky Way galaxy. And let's say we get the signal from them and we decide what do we answer, what do we send to them or what do we ask? And I think the only sensible question to ask is, what do you know? Because this is the only currency in the universe. I mean, they don't need our gold. They're probably not interested in our politics, especially. I mean, it takes 10,000 years for the question to be asked and 10,000 years to get the answer. So the only sensible question, I think, is what do you know about the universe that created us? And this is really science. And then, me personally, I did not do extremely well in science, but what inspired me was that it's really the only way to be remembered in hundreds of years and thousands, in million years, because the only sensible way to be remembered is to put your name on some equation, or discovery. You know, like Einstein equation will be called Einstein equation in a million years. So this is really the only way all physical artifacts will change. So that's really what inspired me.
That's great. How has science helped you as a businessman?
Well, in multiple different ways, but I would say philosophically, science is really a method to analyze phenomena using first principles. And, you know, I did apply it to business. And, you know, like, for example, business I'm in is investments in tech. And, you know, I sat down one day and I started thinking, you know, what are the key factors that I should use to analyze potential investment, and I came up with 3. You know, one would be the size of the opportunity, second would be how good is the founder, and the third, is there any early traction? You know, maybe there are some signs that the company is doing well. And basically, I've been applying these 3 principles all these years that we've been making investments with, you know, some level of success. So from the first principle means analyzing every problem by dissecting it into some simple known truths and then trying to deduce everything from there. And so this is more philosophically, but practically speaking, I had a call with the founder 2 days ago. He is amazing scientist, and he still maintains his professorship at the university. At the same time, he founded and ran the company, which is a $20 billion business right now. And I asked him, why do you maintain this connection to the university? I mean, you are so busy running a company. And he said, well, I recruited all my co-founders from this university. They were all my PhD students. And I maintain connection because I see more and more of them. And also, I'm trying to stay close to fundamental research. So I think it really makes a lot of sense to keep this link.
And what can business offer science? What can business teach science and scientists?
Well, I mean, in terms of offering, I think it's, you know, many things. It's like building facilities, building equipment, supporting research. Like, you know, this morning I just looked up at one particular sector, which is telescopes. And it turned out that all major telescopes were built more or less by private donations. And this is still true today, but it all started a few hundred years ago. You know, one of these telescopes called Lick Observatory is nearby, and it was built by somebody whose name was Lick. So when he was thinking about his legacy, he first thought about building a pyramid. He was inspired by...
But someone had already done that.
He lived in San Francisco, actually. So he kind of found a place to build a pyramid, but then one of his friends said, look, this is like not cool. The cool thing, you know, the 19th century pyramid would be a telescope. You know, this will be a legacy, and that's how you'll be remembered. And he was right. So that's how the biggest telescope of the time was built. And the same was with Mount Wilson telescope, the Big Magellan telescope, which is being built right now, partially financed by Moore Foundation, etc. So Institute for Advanced Studies, fully established by private donors, etc. So there are so many ways business can and businessmen can give back to science.
Fantastic. What motivated you to start the Breakthrough Prize? You started in 2012. I remember some early discussions that we had about it, and you put a lot of thought into how it would be structured and how it would be received. And maybe can you walk us through that process and how it's evolved over time?
Well, initially I think it was inferiority complex. I kind of failed myself, and I thought maybe that's the way to give back to these amazing people who are
I don't think you've done too badly, by the way, but...
making those discoveries. So we then brought some co-founders, Mark Zuckerberg and Priscilla Chan, Sergey Brin and Wojcicki, and we put it all together. And in the last 13 years, we gave about maybe 350 million in prizes in physics, mathematics, and life sciences. But the question is, why have another prize? Because there are, obviously Nobel Prize is a gold standard, but you mentioned, it's called the Oscars of science, and it really was the main motivation, because, nobody is watching Nobel ceremony, except for in Sweden. It's very long and etc. But so we decided to do something interesting, something more like 21st century event, which will be then watched by people around the world. And, we were very popular mostly in social media. We have maybe billions of impressions a year. And the idea is to celebrate scientists and scientific achievements. Like Jim Allison was mentioned a couple of times today, but outside this room, how many people know his name?
Sure.
Or Jennifer Doudna, who co-discovered CRISPR. So the mission of this prize is really to celebrate intellectual achievement, to try to publicize these discoveries, and just make sure that people in the street know the name of at least one living scientist, sure, which they don't right now. So, that was really our mission.
Well, I think it's succeeding brilliantly, and it's wonderful to see, first of all, how meaningful it is to those who receive the award, but also how much uptake it's gotten in the broader community outside of science to both understand the importance of science and also to get a glimpse into what the scientific process and discovery is all about.
It's also the biggest. It's $3 million,
right,
3 times bigger than the Nobel Prize. And
that's right.
And it also became recently, I think, the biggest, the most reliable predictor of who's going to win the Nobel Prize.
That's
like
right.
Jim Allison, Jennifer Doudna, Shinya Manaka, et cetera, et cetera. So all of a sudden, I kind of noticed that our prize is becoming more and more sort of politicized, which is always a sign of some level of influence.
True, true. So maybe we finish with a topic that I know is on everyone's mind, and that's AI. And you think a lot about AI. Yuri, you invest in it. I know you have a vision, probably an evolving vision about the applications of AI. Maybe if we focus on the applications of AI to life sciences, and gives me an opportunity to thank you and Julia for your support of some of the work that's going on here with Raise Health, Responsible AI for Safe and Equitable Health, which is a collaboration between the Human-Centered AI Institute led by Fei-Fei Li and those of us in the School of Medicine and Life Sciences around the university.
What is the mission of that project?
The mission of Raise Health really is to bring particularly generative AI to all aspects of life sciences in the healthcare enterprise, from fundamental discovery, so work that's gone on, building upon, for example, AlphaFold, and now taking it as scientists at the Arc Institute and Stanford are doing, and applying similar large language models to understanding nucleic acid structure and the implications of variants in nucleic acid structure across multiple different organisms, all the way up through what David was mentioning at the beginning of tonight, that is, how can we use large language models to find information within this huge amount of clinical data that we have to predict, for example, who might be eligible for a clinical trial, because we just no one had simply noticed that they had the right combination of features that would make them eligible for the trial, and certainly everything in between. And I guess that's one of the challenges, is it's so broad, and I mean, you started your investing career, as you mentioned, in technology, the internet, and certainly the evolution of the internet was incredible. It was also compared, I think, to AI incremental. I mean, it was in more longer, epoch increments. But what we're seeing in AI, those epochs are incredibly short, or at least they have been. And I guess one question to start out with on that topic is this short epoch between how the models evolve, how their utility changes literally astronomically as they do evolve, is that going to continue? What are the limits? And in particular, what interests you about the application of AI to life sciences?
Okay, well, I would start with the second one. And I think AI would have a transformational impact on life sciences. And the reason I think that's true is because if you look at the universe at the smallest scales, like subatomic particles, etc., or the largest scales like galaxies and clusters of galaxies, you see a lot of simplicity. You only need 35 parameters to explain everything that we observe. 35, which is kind of incredible. Having been able to boil it down to just 35 parameters to explain everything is unbelievable. But the intermediate scale where we operate, that's where complexity comes in. And our fundamental theories don't really apply because of this level of complexity. And that's where I think neural networks come in and can be very useful, because they operate at the scale of hundreds of billions and a trillion parameters. And, this is really the way to describe this level of complexity. Each of these parameters is, being fine-tuned to during training process. So I think this is really why these complex organisms, cells and bacteria and humans, etc., that have, trillions of atoms operating together, the only sensible way to make scientific breakthroughs would be to use neural networks. So I think this is an amazing decade for life sciences, I believe. And then in terms of speed of change, I think we are all a little bit in denial how big the change is going to be, including myself. But when I wake up and think about the data center that Mark Zuckerberg is building, the size of Manhattan, full of chips, the scale of this is enormous, and it's kind of hard to believe that we will be competitive with this scale of artificial intelligence. And yet, we kind of live day in, day out, trying to not see this huge tsunami approaching us. And, it will have profound changes on everything.
For the good?
Yeah, I definitely think so. I think the scale of innovation will be unprecedented, and hopefully the level of prosperity for people. But I also think that there will be a period of disruption between now and then.
Sure.
And this is really the most challenging period.
Great. Well, Yuri, thank you very much for being here with us tonight, for inspiring us in so many different ways, and for your support of the mission here at Stanford and at so many other places that have benefited from your philanthropy, but also, very importantly, from your intentionality and the focus that you've placed on science and the role that science plays and should play in society. Thank you.
Thank you very much.